Okay, everybody. So we've had a minute to try to write the ground state electron configuration for mercury. Now, if I look at mercury on the periodic table, mercury is number 80. So it's actually right next to gold. It has 80 electrons, okay? What I'm going to do is, instead of drawing the whole orbital diagram with all the arrows, I'm just going to think about what electrons fill up in what order, okay? So I know what we're going to do is start from the bottom, just like we did with the arrows, just like with the orbital diagram. We're going to fill up the 1s level with 2 electrons, okay? And then we're going to continue from there, okay? After the 1s fills up, then the 2s fills up with 2 electrons. Then the 2p fills up. We just go in the order of the periodic table. After 2p, it's 3s, and then 3p. Three p holds 6 electrons. All p sublevels hold 6 electrons. And then I keep going from there. 4s holds 2. 3d holds 10. Four p holds 6. 5s holds 2. After the 5s level, the 4d holds 10, and the 5p holds 6. Okay, then I keep going. The 6s holds 2, and I have to make sure that I insert the 4f sublevel here, and it holds 14. So 6s2, 4f14. Okay, and then the 5d sublevel fills up, and if I'm going all the way to mercury, mercury is the 10th element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mercury is number 10. So that's going to be 5d10. This last part of the electron configuration should work kind of like an address. It tells you it's in the 5d sublevel, and it's the 10th element in that row. Okay? So if I look, 5d sublevel, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th element. Okay? There is another way to do that, and this is the abbreviated electron configuration. So we can abbreviate. And the way that we abbreviate is we use the noble gases. So group 18 is the noble gas family. Okay? If I look at mercury, it's number 80 on the periodic table. The noble gas that's before mercury is xenon. Radon is after because it's number 86. But xenon is before mercury. So I'm actually going to use this noble gas as an abbreviation. You can only use the noble gases as an abbreviation. Okay, you can't use any other family of elements, only the noble gases. And you have to use the noble gas that is before the element. So I'm going to use xenon. And by taking the symbol for xenon and putting it in brackets, that represents 54 electrons. So that gets me all the way through the 5p sublevel. So all of this stuff up here is now represented by this symbol right here. So then all I have to do is work my way from xenon to the element that I'm writing an electron configuration for, and that's mercury. So I'm going to go from here. The next thing is 6s2, and then 4f14, and then 5d10. So that would be the abbreviated electron configuration, okay? You just look at the noble gas that's before it, put its symbol in brackets, and then work your way from that noble gas to the element that you're trying to write a configuration for. Another thing you guys have to think about is whether or not something is excited. So we talked about Bohr's model, And we talked about how electrons can jump up a level. So the way that this works is if I had an excited electron configuration, what I notice is that it's just not filled in right, that there's a gap somewhere. So for example, if this one was excited, and it's not any particular electron that has to be moved, it could be any electron that's being moved. Let's say one of these electrons from the 4f sublevel wanted to jump up. Then I might see something like 4f13, right? Because the electron's moving to another level. And then I might see 5d10 and then 6p1. It might jump all the way up to the 6p sublevel. Or it could be that one of the d electrons wanted to jump up a level. So that would be 5d9, because that electron is leaving the d sublevel, 6p1. Basically, all you have to do is identify whether an electron configuration is excited or unexcited, ground state. If it's excited, you're going to see that one of the levels did not completely fill up before another one. Okay, you'll see a gap somewhere because the electron left that full energy level and went up to the next level. It'll look wrong. So if you see an electron configuration that just looks wrong somehow, that can be identified as an excited electron configuration, okay? If it's a normal electron configuration that's written exactly the way that it's supposed to be, that's what we call a ground state electron configuration. So you guys need to be able to spot those. If you see one that looks messed up, you can identify that as an excited electron configuration. Okay, now tonight for the homework, I gave you guys several problems. It's really easy to do the orbital diagrams, okay? For the first one, carbon, you just look it up on the periodic table. If I look at carbon on the periodic table, carbon is number 6 on the periodic table, which means I'm going to fill up these boxes with 6 arrows. You have to keep in mind the Aufbau principle, Hund's rule, and the Pauli exclusion principle. So always start by filling up the 1s. Make sure that you put up and down arrows, right? That's the exclusion principle. Then you move to the next energy level, fill it up. That's 4 electrons so far. We need a total of 6. So I'm going to go ahead and put my electrons there. I spread them out because every orbital needs 1 electron before we go back and double up. That was Hund's rule. So this should be the orbital diagram for carbon. If I wanted to continue and write an electron configuration, then I would just look at it and say, okay, well, I filled up the 1s with 2 electrons, the 2s with 2 electrons, and I put 2 arrows in the 2p sublevel. If I add that up, 2, 4, 6, that equals the atomic number for carbon. We could abbreviate it, although it's a really small electron configuration anyway. If I wanted to abbreviate it, then the noble gas before carbon is helium. Okay, neon is after, so I can't use that one. But the noble gas before carbon is helium. So if I wanted to abbreviate it, then I would write helium in brackets, and then after helium is 2s2, and then 2p6. Okay? And you don't have to do the electron configurations for homework right now, but you are going to be expected to do that for part 2 and for part 3 of this worksheet. So just be prepared for that. Okay, you guys have a good night.